So I'm going to start with mentioning today's date is Friday the 13th, and you're either watching this Friday, Saturday, or Sunday. So I notice I'm going to start with cosine of a double angle. So let me remind you what that is. We actually derived those on the last edition, although we haven't used those in our problem sets yet. That will be on Monday. So I didn't put tangent of 2a on because I couldn't remember if I had derived that or not. But I will later, should I have time and batteries. So there's a sine of double angle and cosine of a double angle. So you'll see the one that we are starting with is actually this one. So going back over here, you'll see it's sitting there in all of its glory, and it has some secrets to reveal. Let's go over here on this side and do the simpler derivation first. And over here I want to get sine squared of an angle by itself. So algebraically, I'll just move over that 1 and divide, and that gets sine squared by itself. Now I want to clean that up. I'm going to put sine squared over here, and I don't like that negative sign in the bottom, so if I change the top and the bottom, if I multiply the top and the bottom by -1, then I get 1 minus cosine of a double angle over +2. So that's a better form. So that's where I'm going to stop with that one. And we call that a power reducing formula because it starts with a quadratic, a squared term, and it ends up with an expression that is not squared. It's to the power of 1. So we've reduced the power from 2 to 1. So we call it a power reducing formula. And lo and behold, one day you'll be sitting in calculus class trying to take the derivative of an expression, or I think it's actually the integral of an expression of something that looks like this, and it'll be like a dead-end city until you remember that these are equal. This is very easy to take the integral of, and this is not. So we will use that in your future math. And if you should not take calculus, I'm keeping that door open for you, so you may walk through it or not. Over here, I'm going to start with the same expression that I started with here. I said, wait a minute, this is a trig ID, so let me call your attention to add it to your list. All right, another one that comes from the same formula, I'm going to take, instead of getting sine squared by itself, I want just the sine by itself. So this will be the first steps are the same. Cosine of 2a minus 1 divided by -2 equals sine squared a, but this time I want sine a by itself. So cleaning this up and moving everything where it's nice and neat, just like I did on the other side, I'm going to get 1 minus cosine of the double angle over 2. That's where I was on this side. But I want sine a instead of sine squared, so I'm going to take the square root of both sides. Remember, it creates a plus or minus situation on the right. So I have sine of an angle is plus or minus square root of 1 minus cosine of 2a over 2. Now it turns out I was promising you a half angle formula, and here is an angle and here is twice an angle, so where's the half angle? Well, mathematicians have a little trick that we use, and that is when you have a formula, you can put in anything that you want here as long as you're consistent and put the same thing here. So I can put in sine of a star equals plus or minus square root of 1 minus cosine 2 star over 2. That's not always that helpful. So I could put in sine of a French fry. Plus or minus the square root of 1 minus cosine of 2 French fry divided by 2. But that's not that helpful either. So let's say that I'm going to put in sine of a over 2. I can do that as long as I put the same thing in here that I put in here. And that's what I need. I need a half angle formula. So I chose this one because look what happens. When I get to the 2 next to it, I put in my angle divided by 2 over 2. These are all under the square root. So, and this simplifies very nicely right here. The 2's cancel, so it gives me a nice and neat formula that I can rely on. Sine of half an angle equals plus or minus square root of 1 minus cosine A over 2. And that is another trig ID, half angles. And we'll hopefully get a chance to show you that, how to use that on this video. Alright, it turns out we can start with the other double angle from cosine. Where's my list? Over here. Well, this one was 1 minus 2 sine squared, and you can see over here we could also use the cosine of a double angle is 2 cosine A minus 1. So if I start with that instead, let's see what flushes out. So cosine of 2A equals 2 cosine squared A minus 1. And I want you, without me, to go ahead and solve that for cosine A. It's hidden in there. So you'll move the 1 over, divide by 2, and take the square root. And then replace A with A squared, and see if you do not come up with this trig ID. The cosine of half an angle equals plus or minus the square root of 1 plus the cosine of A divided by 2. All that's under the square root. So this one will lead to that, and that's the next one. Without seeing every step, it will work very much like the one above. Let's go over here on this side and use the same trig ID, the double angle one, to make another power reducing one for us. So cosine of 2A equals 2 cosine squared A minus 1. And this time I want to solve this for cosine squared A. I don't want to break it down any further. So when I do that, the 1 comes over by addition, divide by 2, and we get this. Let me put it on the side that I want it. And I'll put the 1 first, just for good looks. So that is another power reducing formula, and now you know why, because this is quadratic, power 2, and on this side is power 1. Again, your lucky day one day in calculus class when you remember that, or at least can look it up. So the power reducing formula for cosine squared is right here. Alright, there is tangent to mess with, so we'll go back over here and we're going to do the double angle. Shall we do that first? Let me check my notes here. Yeah, that one will be pretty nice to do, I think. Tangent of A over 2. Tangent of A over 2. Tangent of A over 2. Hold on a second. Alright, I'll start that on the back. So we talked about sine of A over 2, cosine of A over 2. So now it's tangent of A over 2 time. So, and then we'll do the power reducing and see if there's any video time left. All right, so let's start. We're looking for tangent of the angle, half of an angle, and we know the relationship of tangent to sine and cosine. So we can say this, that sine of half an angle and cosine of half an angle is tangent of half an angle. And now I'm going to pull out a little trick, and I'm going to multiply the top by 2 cosine of half an angle and the bottom by 2 cosine half an angle. And so why would you do that? Because something nice falls in my lap. This times this is 2 sine half an angle, cosine half an angle, and on the bottom I get 2 cosine squared of half an angle. That's what this times this is. Alright, so do you recognize this right here? Let me go back, keep going back to our formulas from the day when, well, I guess it was like Thursday night, and we haven't used them. Here they are. So, do you see that hidden in one of those in our double angles? Look again, 2 sine of half an angle, cosine half an angle. Do you see how it follows this pattern right here? So I can write that as sine of twice whatever is there. So let's go and see what's there. So I can rewrite that as sine of 2 times whatever is here, which is a over 2. The 2's cancel, so that whole top just becomes sine a, and on the bottom we have 2 cosine squared a over 2, and that one is also almost a trig ID. Let's see which one it's almost like. You see which one? It's almost like that, but we need a -1. So when mathematicians need a -1, they put in a -1 and a +1 to make up for it. So now we have a similar situation on the bottom here. We have 2 cosine squared of a over 2 -1 is very much like that. 2 cosine squared a -1, so that's going to equal cosine of twice whatever's sitting there in that spot. So we're going to get cosine of twice a over 2. And this +1 can't be forgotten. The 2's cancel. So cleaning it all up, we have sine of an angle left in the top, cosine of an angle +1 on the bottom. And that is one form of tangent of a over 2. There's another form that we could derive very similarly, but let's see if that form will get us through our problems. There's several other forms, but I'm happy with that one if you're happy with that one. I guess the only other thing to clean up is the tangent power reducing formula for tangent. So let's go back on this side. Remember we were doing our power reducing formulas where sine squared went down to cosine without a squared term, and cosine squared went down to cosine without a squared term. Let's do the same sort of thinking for tangent squared. But I'm going to use this formula and this formula. In fact, I might even fit it right in here so that you can see both at once. So I can say the tangent squared of an angle is sine squared of an angle. Let me get this steady. Sine squared of an angle divided by cosine squared of an angle. So we know that relationship. So putting in sine squared of an angle up here, I get 1 minus cosine of 2a over 2 divided by this one down here. Cosine squared is 1 plus cosine of 2a over 2. So when I flip this and multiply, The 2's cancel, and I end up with 1 minus cosine of 2a